This is probably a topic that is new to many of you, and I hope we will never have a chance to use this. I don't recall our using this concept in this class. It should typically not be used in any object-oriented systems, but it is there as a facility, as a last resort in some situations. Let's see what that is. Of course, this topic, as you can see, is called Runtime Type Identification, RTTI. What does it mean? Sometimes we might have a situation where we want to know what the type of an object is. For example, if you have a collection of shapes and if you want to find out the number of circles in that collection, you could have rectangles, polygons, lines, circles, triangles, etc. And you want to know how many circles are there, then you may have to go through all the elements and then ask each object, are you a circle? Are you a circle? And if it is a circle, you add one to a counter. So in such situations, you may want to have the ability to check what the type of an object is. Usually this shouldn't be needed. You should be able to solve 99% of your problems using dynamic binding, and this is not a very elegant solution, but there is a way of doing this in object-oriented languages. Let's see how we can do that in Java. Suppose I have a shape object. So the class name is shape, and the reference is also called shape in lowercase. We can ask any object. Of course, it is a reference, but we are ultimately asking the object to get its class. What is the class that you were created in? For example, if it is, shapes could be of many different types, because by polymorphism, this could be pointing to a triangle, a circle, a polygon, line, etc. So what is the exact class? There is a class object associated with every object. So what is the class name? So shape.get class gives you the class object, and you can get the name of the class in which this shape object was created using the get name method. And then you can ask, if it is equal to a circle, do something, maybe add one to a counter. So this is called runtime type identification. This uses what is called a Java reflection. You can investigate an object for its methods, for its constructors, for its fields, and its class, as we did here. This is called the reflection mechanism in Java. So using the reflection mechanism by getting the class, its name, and checking if it is equal to a specific class name, you can figure out if the shape was created as a circle object. That is one way of doing runtime type identification. Another way would be using the instance of operator, which we see in another video in this collection. But let's see what is wrong, what can go wrong with this. Suppose I type circle all in lowercase, all letters in lowercase, then this will not work. This will compile correctly, but this will not work, right? Because there may be no class called circle with a lowercase c. So I am thinking that I typed the correct class name. Java has no way of checking whether this is meant to be a class name. So my code has a bug. So you might want to use this if shape instance of circle. So you could ask an object reference, were you created as a circle object? Shape instance of, it is a one word, no space here. So this is an operator. If shape was created as a circle object, it will return true. But the thing is, this will also work for any type that circle inherits by extending another class or implementing an interface. So if circle was of type shape, then shape instance of shape would also be returning true. So shape instance of object would also return true. So this would be okay as an alternative to using getClass.getName, because Java will check that circle is indeed a class that is known to the program. So, but it can also be used for other types that circle has extended or implemented, and it would return true for all of them. So the two are not quite the same. The reflection RTTI and this are not truly equivalent.